Hello, hello, hello. So in the last video, we saw how to define, or kind of define, a for loop, a version of a for loop. We're going to go from the opposite direction now. Instead of working with iterables in defining a for loop, we're going to define our own iterable slash iterator, like a range class, but we'll call it counter, okay? So imagine we have a counter class like this, and I want to be able to do something like for n in counter from 50 to 55. And then I want to be able to do print n. That should give me 50, 51, 52, 53, basically the same thing that I would get with a range. But we're going to define our own class called counter. And counter will take care of everything. It will return an iterator, and the iterator will have a next, or will return something when next is called on it. So let's just get going before I stumble over my words anymore. First thing we'll do is just define a class, or already stumbled. We'll define a init. There we go. And when we define a counter, we'll pass in we need self. And then let's just call it low and high, like this. And then we'll just set self.low equals low, self.high equals high. Okay. Now the very first thing I could show you, we have to define this def iter like this method. And whatever I return in here, when we call iter on a counter, which is what this for loop will do, is what will be returned and what needs to be an iterator. So let me just show you, if I comment all of this out right now, and comment this out as well. If I tried to do iter on counter, like I make a new counter, let's just call it C equals counter 0, 10. If I tried to do iter C, it complains to me, counter object is not an iterable. And it means that for something to be iterable, it has to respond to iter and return an iterator. So if we define our iter method here, and we could start with something really simple and silly. Remember that iter needs to return an iterator. So we can't just return something dumb like a number or a string like hello, but we could return iter hello, because remember what this is here. When we call iter on hello, it's a string, it's iterable. This returns the iterator, string iterator, like we saw in the last couple videos. And now if I try it, we shouldn't get an error, and we don't. So I actually have enough now to do for x in counter 0 to 10. It's not going to do what we want, but I could print x. And what will happen here is that counter, the for loop is going to call iter on counter. When we call iter on counter, it calls this. So this is one of those dunder methods like length. We call len with this, the non-dunder function, but behind the scenes, it's calling the dunder len that is defined on a list or on whatever, a deck or a card. Same thing here. So we define dunder iter, and then when we call iter on a counter, it's going to, iter behind the scenes calls dunder iter. Very confusing. Okay, so here, that's what we've done. But it just returns the string iterator hello. So it's not going to do what we want. It's not going to give us numbers from 0 and 10. It gives us hello. But it's an iterator. It's working. What we want to do instead is actually return self. But the problem is if I return self right now, I mean, you'll see, it's going to try and call next on that. There's a problem because it's not an iterator just yet. So we returned self. Basically, when you call iter on counter, which isn't an iterator, it just returns counter, which isn't an iterator. So that's not going to work. The next thing we have to do is define the behavior of next. And this is dunder next. Next, we call like this, like in our previous example here. But when we do this next on an iterator, it is calling that iterator's dot dunder next. So we have to add dunder next self, and we could do something really dumb, like just have it return, 1 over and over and over. And if I actually ran this right now, I believe this would be an infinite thing because we're not stopping at any point. Every time you call next, we get 1, 1, 1, 1, 1, 1. If I did that, there we go. Okay, stop this before I ruin my computer. So we now have an infinite iterator, which that's actually a thing, but that's not what we want here. What we want, we could just return 1 over and over and over, but we want to return starting with low, and we want to keep adding 1 and low and 1 over and over and over until we hit high. So rather than calling this low, I'm going to call it current, and I'm going to set it to be low. So in this case, 0. Then what we want to do, well, first we should check if self.current is less than self.high. If that's true, this is where we're going to basically return the number and add 1. So we would do something like num equals self.current, and then add 1, self.current plus equals 1, and then return num. And we need to do it in this order because if we return first, it stops the execution. And so if return was up here, we would never add 1 to current and be stuck in that infinite loop. So the first time through, we get 0, and then it adds 1 to current. So current is 1, but then we return 0. Next time through, num is self.current, so num is 1. Self.current is now 2. We return 1. And we keep going until we hit the end where self.current is no longer less than the high number. If that's the case, we just want to raise stop iteration just like this. And that's actually all we should have to do. Okay? So now what happens? Let's walk through this. When we call right here, what we have, for x in counter 0 to 10, the for loop is going to call iter on this instance of counter, and iter returns self. Earlier we had it return like a string iterator or something, but now that self is actually set up with a next method, it is able to call next over and over and over until next returns stop iteration. So if we check it out now, there we go, 0 to 9. And we could play around with this, change it, instead of 0, let's go from 50 to 70. Awesome. So we're not quite at the point of range. We don't have a step where we could do -1 or something, but that wouldn't be that much work to implement. Why you would do this exactly, I'm not encouraging that you need to rewrite range or something. This is more to show you that it's possible. In the next video though, I am going to show you how we can take the deck class we wrote a while ago and make it iterable.